First of all, welcome to Confidence. This is my first time in Poland and I enjoy it very much. Before we go into the essence of this presentation, I'd like to introduce myself. My name is Krakow. On the internet, on the web, you can recognize me as PDP. I'm an information security researcher, and I do a lot of work for Citizen and some other institutions. Citizen is basically a cutting-edge think tank. I was planning to actually show you some videos, but I realized that I cannot connect to my audio on the computer, and therefore, if you want to see these funny videos, I can show it to you later. Basically, I'm going to skip this slide since Adrian introduced ourselves, and I don't have much time, and I have about 80 slides to go through, and you pretty much know what is it. Other things that we are doing is one of our current projects is House of Hackers. So if you actually want to join, you're more than welcome. It's actually a social network. We're actually experimenting with this thing. We don't know where it's going to go, but hopefully it's going to go into a good direction. Anyway, today we are talking about client-side security. This talk is basically an overview of some of the work that I did, and also some other members of Citizen and people outside of Citizen that are on client side. Before we move into the slides, I just want to talk a little bit about my objectives when I was doing the research. The first thing that I was trying to look when I was researching client-side security is to look at design issues, because we have the common vulnerabilities, input validation vulnerabilities and stuff like this, but very rarely we actually pay attention on designer problems. Design problems, of course, are more severe because you cannot just fix them. You know, you have to take a very careful, go through a very deep process, basically deciding whether actually this design should continue working for you. I was trying to actually find new ways, pretty much play around with things and mix ideas. So most of the exploits you will see today are basically combination of a few things. Also, I'm not actually a bug hunter, which means that I don't do actually vulnerability research only, but I'm actually using this stuff into my own work on a daily basis when I need to, for example, do penetration testing for some company or something like that. Now, first of all, we need to understand what is client-side security. The most important thing that we have to actually learn from this presentation is that everything is in the symbiosis. We cannot just take a single component and do penetration testing or testing for this single component there. We actually put this component into a sort of an environment, and then we actually test it with the rest of the environment. I said that the clients and servers are in constant symbiosis, mainly because they actually depend on each other. This dependency is basically the security model of the clients, also often depending on the security model of the server they're connecting to. And also the server security model depends on the security model of the client. I can give you a simple example. For example, you can have a very secure VPN, for example, setup, but if one of your clients is compromised, that will allow the bad guys into your protected network, although your network is set up correctly. On the other hand, if your server is compromised, that can actually leak a lot of information that the client has provided you, or give the attackers access to your server and in such a way attack the clients, the individual clients. And we see actually a lot of these iframe attacks popping up here and there using SQL injection. This is very important. Now, the next part of this presentation, after skipping this sort of introduction, is basically a rundown of various exploits, various vulnerabilities that were found during the process of research. So this is basically a very gradual process. We didn't just sit down there and say, okay, well, now we're going to research client-side security. It just happened naturally, building more and more things. The first interesting attack was the Gmail hijack technique. It's actually a simple cross-site request forgery attack, but it had a very big implication to a lot of Gmail users. The attack goes like this. Basically, the user opens their Gmail box. Then they go visit a malicious website while being logged in still into the Gmail box, inbox. And then what happens is that you don't see that, but in the background, there is actually a request forged on behalf of the user to the Gmail account using the Gmail mobile interface. So actually, we're not sending here, we're sending to actually what mobile users will usually see when they're accessing Gmail. And this simple cross-site request forgery attack will add a new rule into your filters list that will basically instruct Gmail to forward every single email that you received into their account. So they essentially hijack your inbox completely. Now, they can not only probably in some way reset your account or do some other things, but they can do also a lot of other things. I'm going to mention them at the end of this sort of preview. The cross-site request forgery attack can be performed with something as simple as that. This is a simple cross-site request forgery utility which converts everything that you send to it into from get to post. In this case, just notice that we have CF2 email. We actually forward this thing to Evo inbox, and basically this specific rule actually instructs Gmail to forward me everything that has an attachment. I mean, we can actually do a very generic filters here. In reality, when you actually send this information to the request forgery utility, it will be converted back to a form request, which is going to look like this. That form is going to auto-submit with this form.submit instruction at the bottom, and of course compromise the Gmail box. As I said, someone got hacked, so this is actually a real case. Although I disclosed the information privately to Google, and they fixed it, apparently there was another way of doing this exact same thing. So there was this case of David R.A. I'm not sure if you actually pronounce his name, but I'm giving him as an example. He has a good website with a good ranking, and essentially someone used that attack to compromise his Gmail, and then he used his Gmail account to actually compromise his domain name, because he actually created an email, sent it to the ASP, and of course the ASP will ask for confirmation, but since you can actually read that emails, you can actually correspond to that confirmation, and basically the domain was hijacked, was moved to a different place, and of course the attacker was asking for ransom. And fortunately for him, that case was resolved very quickly, because it just got traction and a lot of people got involved into the process, so people helped in that case. But it's a good example of what a simple cross-site request forgery attack can do. Another thing that basically Adrian sort of talked a little bit about actually talked a lot about, is the research that was performed on BT Home Hub. This is again actually an example of a cross-site request forgery. Again, it's a client-side. It's a particularly client-side security vulnerability. In this case, you enable remote assistance. I'm going to skip this stuff because I have plenty of other slides. This is the other one, disabling the wireless connectivity. And of course, we have the code jacking, which to me is my favorite one, since it's just fun to make your phone ring through a website. Right. And the other ones, no, I'm actually going to repeat that again, what he said. This is another research performed by Mario from GNU Citizen. The interesting aspect about this vulnerability is that this is the spy super toy, Your phone converts into a bug, basically. So the attackers can actually instruct your phone to become a super bug and actually sniff everything that happens within the survey the entire room. So if you're actually doing a business meeting, so everything that you say within that space, the attackers can listen to, record, use it for whatever the reasons they want. So pretty much this is like in the movies Hackers, Basically you actually listen what the guys do. Now this is an interesting attack which I happened to develop because at the time when Adrian was researching this client-side security vulnerabilities, not client-side, embedded devices vulnerabilities, one of the interesting things that we were thinking about back then is how we can upload our own custom firmware into the device. Is it possible to actually, you visit a site and the site completely changes your device, it actually uploads a custom firmware, and this is how we do it. Actually, it's possible. A lot of people don't know that actually we can do a cross-site request forgery on file upload facilities. Now, file upload facility is a little bit different from small forms, because usually you don't have access to what exactly you're uploading, because if you do, then you can actually steal information from the user. So the same origin policies of the browser actually prevent you to do anything interesting with this sort of a thing. However, Flash is a lot more kind to us, and it gives us the facilities to actually successfully forge file upload facilities. So in this case, I'm actually constructing a simple function. This is all Flex, it's a simple Flex script, MXML. This simple function on app init basically creates a new request. If you see there are .data right there, This is basically contains the entire payload, unescaped of course, because otherwise it's going to break the rest of the semantics of this page. And this is compiled. And when we actually submit this information to the remote device, that will upload a firmware. Of course, in this example here, we don't upload firmware because I cannot squish an entire firmware like binary into a slide. But this is basically the example. Now, the interesting thing about it is that, of course, if the attacker wants to perform that successfully, there's a chance of completely breaking the device and rendering it useless, but it's still an option. The same method can be actually done with normal browsers, but if you notice, it's a little bit weird. This method was developed by Kuzo 55. It doesn't work everywhere since Opera doesn't like it, and some other browser doesn't like it. But it's much simpler because you don't need to use Flash. I prefer the Flash method because it's more complete and allows me to upload very big chunks of data. This one is a little bit restricted, but if you notice, the actual form request is a little bit corrupted. I mean, this is not actually real how a form should look like in the browser, yet that actually forges a file upload sort of thing. This is another interesting attack vector, the QuickTime vulnerability, which actually attackers can use to compromise your browser. Now, the first thing is a little bit history. Now, QuickTime, a little bit of actually details. QuickTime has it's a very big platform. You know, it was designed initially as just to play movies, and later it was basically. I mean, right now with QuickTime Pro, you can actually run an entire video studio there. It's actually a very advanced thing. So it has a lot of supporting formats and a lot of things. One of the interesting things in QuickTime is something called QuickTime Media Links. The media link file is a simple metadata format which contains information about what file to play, how big the file should be, and what to do after this file finishes playing, and whether you should autoplay it. So it's a simple meta format. The interesting thing about this like a meta format is that we can supply some arbitrary information to it. For example, what to do after the file finishes playing. Now, the other interesting thing about this file is that if we actually create this file, although it's a simple XML file, we put it in the text file, we change the extension to any of the extensions at the bottom, and we open it with QuickTime, it's going to treat it as that file. Which means that although you're opening MP3, you think that you're opening MP3. In fact, that might not be actually an MP3 file. The same thing with the video or PNG, PIC or whatever. As long as your QuickTime player opens it, it's a problem. Now the problem, the actual attack goes like this. You notice that we have a couple of fields there. We have something called embed source equal a.mp3. This is basically we sort of instruct QuickTime to play a dummy mp3 a file which doesn't exist, so it's going to skip it. Then we say autoplay because we want that attack to start immediately. Then we have something called qtnext. Now qtnext is a field that instructs the QuickTime player to start something else after this mp3 file finishes playing. Now this could be a page, but this could be also another mp3 file, so you can actually chain them. The problem here is that the QuickTime does not take into consideration, because probably was built for Apple, does not take into consideration the environment of Windows, and it uses a functions into the Windows in not actually correct way. So therefore, we can actually do some sort of a shell escape sort of a functionalities. Now, if qtnext will open a URL right into the default browser. Now, if your default browser is Firefox, we can actually append this long string there, -- Chrome. Now, Chrome basically will execute the next URL, which is JavaScript URL, into the Chrome zone of the browser. And the Chrome into Firefox is actually the most privileged zone into the browser. That's like local zone in Internet Explorer, actually more advanced. And all extensions that you have in your browser basically run under the Chrome. So in that case, here we can open calculator application just by opening this file. But keep in mind that the attackers can do a lot more than that. They can actually completely backdoor the browser, modify every single component inside, install a hidden extension within your browser, and hide itself. Like the extension will actually remove itself from the add-ons list, and there's all sorts of actually interesting things. So this is basically a remote code execution in a way without using traditional bugs. This is basically a zoom in of the actually interesting bit of this exploit. Another interesting example of a kind of a similar vulnerability was the Internet Explorer hack for Second Life. Now the interesting thing about Internet Explorer is that it's Although Firefox will encode meta characters, if you have single quote or anything like that, it will convert them to their hex notation just for safety reasons. Internet Explorer doesn't do that. And they have actually reason not to do that. The reason is because they don't know whether, if they open this actually URL and they pass it to the application that's supposed to handle this URL, they don't know whether the application actually understands your encoding format. There's a lot of legacy stuff around Windows, so that's why they don't want to actually, implement this sort of thing. However, because of the second life association into the registry does not use proper quotations around the executable, and it has some interesting also parameters, we can use this double quote after the // to actually escape from the command line in a way, and then we append this out to login thing and login URL. Now the auto login instructs the QuickTime the Second Life application to log in automatically without actually asking for username and password. And in the previous versions of Second Life, this information is actually stored by default onto your computer. The next parameter is very interesting. It's called login URI, and this is basically the authentication server with which we can log in. Now Second Life has a very complicated structure because they have to manage a lot of requests, a lot of information, so they have a farm of computers, and not a single server can be used for authentication. You can use many servers for authentication. So in this case, we actually create our own PHP script that's going to actually log in, not log in, but record everything that the Second Life client sends us. The information that we get from the Second Life client is this. Basically, this is pretty much a dump. It's a simple XML RPC request. Notice that we have something called passwd. This is actually unhashed version MD5 hash password. Although we can crack that MD hash password, keep in mind that in order to log in into Second Life, we don't have to do that. We can just simply replay it, and we're going to be authenticated as that user. Now, the problem here is that because Second Life becomes so big, now people will start exploiting users in Second Life to steal their money, because now you can translate Linden dollars to actually real dollars, and it has a problem. Of course, avatar theft, all the stuff that you do there, some people actually might take it quite seriously, especially if you spend like an entire year into this environment. And the script that I use to actually compromise the Second Life user is that's a PHP file that basically records all the information that I need. So it's simple. Now this isn't something very interesting, and it's kind of dear to me because every time I try it, it works 100%. I call it the command fixation attacks, and they work for Microsoft Citrix, and they work for Microsoft RDP in a little bit different ways. Now, both implementations, they allow you to actually have remote desktop functionalities. Citrix uses ICA. The format is a little bit like WinINI, and Microsoft RDP is actually completely different. Now pay attention on this sum command here. This is text in bold. Now this is basically the initial program that we're going to execute once we log in into the environment. That's the trick. So first of all, we're going to look into the Microsoft RDP file. So here's the actual RDP file. All the RDP file has, it says alternative shell, and then we say cmd.exe/c. We actually say to TFTP to some site, get the some executable and execute the executable, and that's all it is. Now, this one is going to ask you to log in. So, for example, let's actually think about the attack vector. The attack vector looks like this. I'm sending an RDP file to a user. The user clicks and opens that RDP file and tries to log in. When they log in, they get exploited. Now this one is less malicious because it requires the action of logging in and also trusting me. So that's why it's going to require a little bit of social engineering. Here's actually something that I did for fun. It's basically a simple email, sent apparently from the IT administrator that says, well, we did some changes in our RDP service. Please try to log in and see if it works. The interesting thing here is that RDP files are not filtered at all. I mean, they're just simple text files, and usually people use them all over the place, especially if you have a Microsoft sort of environment. Now, the most interesting one is the Citrix attack. Now, the Citrix attacks does not ask you to log in if you have Citrix neighborhood installed on the same computer. We actually can use this flag here, which is called auto log on or allowed on. And then also we use this sort of thing, which is called use local user and password equal on. Now, basically, that will enable automatically something called pass-through authentication. So it's going to take your credentials that you have on your box, and it's going to use the same credentials to log in into Citrix server. And again, we have something called here initial program. We use cmd.exe as initial program. We TFTP to some site. We download the executables that we want, and we run them. Now, this one is very evil, and I'll tell you why it's evil. Because you don't see it happening. So imagine that you're actually in a corporate environment, and you visit the website, and that website has an iframe embedded into the source code. As soon as you visit that site, that iframe will start the ICA file because it's all associated with the Citrix application, Citrix client application. The Citrix client application will find the first server into your Citrix neighborhood. Just keep in mind that I don't even specify the IP address there. Pick up the first server, it's going to try to out-log into that server, and as soon as it logins, it will execute this program, and it's going to close down. And in that case, we actually use the user as a stepping stone to attack Citrix, or the user's environment into that Citrix box. So actually this thing works, and just a couple of days ago, some of the readers of GNU Citizen, he sent me I sent a comment on this post when I was discussing this attack that says the Citrix actually found a solution, but you have to actually modify the registry, which I recommend if you have a Citrix environment to either modify the registry in order to prevent this thing from happening, or basically remove Citrix neighborhood and just leave the Citrix client. It's possible to do the exact same thing with ActiveX controller because it's actually marked with safe for scripting. We can also enumerate servers. If we don't know the IP address, we can actually start enumeration of the whole network and actually find them, because again, the ActiveX controller allows us to do that from the browser, and we can connect to any arbitrary server and even actually try brute forcing usernames and password. It's going to be a very slow process. It takes about maybe 20 seconds because you have to delay the connection in order to see whether it's working or not. But it's still a possibility. However, the other method I like it better. This is another attack. This is actually a proper Chrome execution into the browser. Although we can make sure that the browser is very secure, it's always the case that third-party developers that screw up at the end of the day. So this is Firebug, and in Firebug there was a problem. And the problem was that we can inject scripts, but when we inject the scripts, they start rendering into Chrome. Because of that, we can write this simple function, which is called run file. It uses the XP-COM architecture to run a simple executable. Again, we can do a lot more than that. This is just as a proof of concept. Now, because we are limited in space of the injection, this thing had to be broken into smaller pieces, and each one of them injected a couple of times, and then at the end we need to evaluate it in order to actually put it back into the Chrome namespace. So this is how basically how we break it. We use a simple push into array, and we actually write the whole payload inside. After that, we can create a simple function that does exactly the same thing, but it's more dynamic, which is called execute. Now this is actually in a web page. You visit evo.com and it starts running right there. This one breaks again, whatever you send as a P flag is going to break it into smaller pieces. It will inject it into the Chrome, and it's going to execute it using the run file function. And then from the browser, we can just use execute and whatever we want after that. So we can actually start applications. We can also install different plugins or hijack your cookies or whatever. Cookie is going to be your least problem. Another example of escalation into Chrome, this one affects Internet Explorer. Now, what most people don't realize when they're using instant messaging clients is that these are actually browsers. Now, Google Gmail, actually what you see there, this is actually Internet Explorer. Skype, the actual box where you type it, this again is Internet Explorer. Yahoo is Internet Explorer. There's no innovation there. If it's Internet Explorer, this means that I can run JavaScript inside. And the question now is whether this sandbox is secured to run my JavaScript. Does it restrict me of actually doing a simple Windows scripting shell primitive commands? Most of the cases they don't. There was problems with Yahoo, the AIM, but this one is particularly in Skype because I was involved to some extent to this research. So basically there was a vulnerability found in Dailymotion, which was a cross-site scripting attack. Of course, nothing interesting there, apart from stealing a Dailymotion user account, which is not that much of a value. But the interesting thing is because Dailymotion is actually a video partner with Skype, you can actually embed Dailymotion's video into your Skype moods or Skype conversation or whatever. This means that when I go to the page, I actually run JavaScript. I can run from that process scripting JavaScript into my Skype box. What happens is that Skype uses Internet Explorer, but unrestricted version of Internet Explorer, which means that I'm allowed to do whatever I want. So if we inject this simple payload, which uses ActiveX object to create a shell, and then we actually execute the command, that will work. That won't work if you actually directly visit the website with your browser. It will never happen because the browser will say that's not possible to happen. But if you go there with Skype, it's going to work. However, the problem here is that, taking the user to that page via Skype, and the easiest way to do that is to use the Skype protocol. So here, with the Skype protocol, we can say multimedia mood, which is going to actually start an action of setting up a mood into Skype. And then we can say the partner is MetaCafe, and we can say the ID of the video is the ID where is across as cryptic. Now, as soon as a visitor visits a website which has an iframe that actually points to that URL, the attack starts automatically. It starts the Skype, it launches the attack, and the box is completely compromised from there. Again, this is credits to Miroslav. I cannot pronounce his last name. He found the first cross-site scripting vulnerability. He didn't know how to use it. Then Aviv Raf, of course, he found the second cross-site scripting vulnerability in MetaCafe. He found how to use it. And the other interesting thing, which also contributed to this research, is actually pawning Skype from Wi-Fi. Although most of the Skype traffic is actually encrypted and you cannot see what's happening, sometimes Skype gets ads and things like that, especially if you're on Dailymotion. Now, this information is not encrypted at all. And if you're on a Wi-Fi network, I can see that information. I can also hijack it using AirPwn or Karma attack. And when I hijack it, I can, for example, when you're actually rendering a ad into your page, I can replace that with my malicious ad, which is going to start the same exact logic. So if you're, this is probably the simplest way of winning a pawn-to-own competition, because your default gateway, and it will work. Another interesting attack was attack in a Firefox. It's a jar URL handler issue. Again, we're combining technologies again, and when you develop a single technology without putting it into a context, you don't know how it's going to behave. It's the same problem here. We use jar. It's a special protocol in Firefox that allows us to get content within zip files. The problem here is that when we do that, the browser doesn't actually take into consideration that everybody can upload a zip file anywhere. Most of the document formats, like the Microsoft 2007 or 8, I don't know, document format is actually a simple zip file. If you change the extension from .doc to .zip and you double click, it's going to open up with XML stuff inside. The OpenOffice document format is again a zip file. There's tons of other actually things which are also zip files, and I'll show you how I can actually make a picture look like a zip file. So a file can be a picture and a zip file at the same time. So there's no actually real way of knowing what exactly you're looking at. But attackers can actually force certain sort of a view. And because of this means that every site that allows me to upload a picture or allows me to upload a document or anything like that, I can cross that script through this jar vulnerability. Of course, that was fixed, but that was the case back then. The other problem that basically that happened from this vulnerability is that now we can actually access every single site that has 302 redirect, which means that if I actually have just a site and I append a URL that the site redirects me to that URL, I can do a cross-site scripting vulnerability right there. Because Firefox does not take into consideration the second domain of the redirection. For example, here we're using actually Google Groups. So we can actually do a cross-site scripting attack on Google. It does not take into consideration the actual redirection, which is evil.com. This is where the same origin policy should be locked to. And it's going to just take the first one as a lock point. And of course, this means that now we can host our malicious files into some arbitrary domain, which we own, with some payload HTML file that we want to inject, and we actually use jar on Google Groups, and that all things is going to be, browser will believe that all this stuff are actually coming from Google, which is not the case. The other things that which I was playing heavily when researching this stuff is the Java runtime, and you have a lot of interesting stuff there. The interesting thing about client-side security is that you actually have some restrictions. So the browser enforces restrictions, Flash enforces restrictions, and Java enforces restrictions. However, when you put the three together, you don't have any restrictions, because when one of them is restricting on one side, the other one it permits you to do that. So basically, when you combine the three technologies together, you have no restriction whatsoever. You can do whatever you want. So the Java runtime, if you upload, let's say, a zip file or class file or something like that, it's very easy to poke behind the firewall, because you'll be able to create sockets from actually where the class is located to the same machine. We know that actually the firewall is actually very weak from behind. From outside, maybe there's some firewalls. Behind, there's nothing. It requires some social engineering, and as I said, it takes pictures like jars, and this is how it works. If you take a sample picture, right, and just any picture from the internet, and we compile a simple class file and put it into a jar, and then we put them both together. The first part of the file should be the picture, the second part of the file should be zip. So we can do that on Windows with binary copy, or we can do that on Windows with concatenations. Now, the problem here is the following. If I take this file and I put .jpg at the end and I double click it, it's going to be a picture. It's going to show up as a picture. If I open it in the browser, it's going to show up as a picture. If I run it through any function to detect whether this is a picture, it's going to tell me that's a picture 100%. However, if I change the file to .zip and I double click it, it's going to open up. Now, why this is happening? The reason it's happening is because both files have a different file structure. When actually trying to detect whether this is a picture, I'm starting from the top and I'm reading the headers, and I know that this is a picture. However, the zip headers are at the bottom. So basically, no matter which way you say it, it's the actual file, So it's open to interpretation what exactly you're looking at. So as I said, a document file can be a picture at the same time, So it's also an interesting way of actually hiding data. But also, if you can upload this stuff into any server, that's going to cause a problem. Another thing which I actually quite like, it's a very stupid but it works everywhere, is this drive-by download attacks. And to me, it's surprising how many people will click on install or something like that. And this is even easier. You can upload any Java file anywhere you want and sign it yourself. Call it whatever name you want. This is all the certificate you can generate it yourself. Most people will probably click run because they want the application to run. Not only that, the problem is that banks are trying to teach you to click on run, because a lot of banks I've seen, they actually have interfaces that rely on signed Java applets. So you won't be able to access your bank account unless you click on run on this box. But this also teaches you when you go to a different sort of a site to click run again. And not to mention, as I said, for the name I put Super Mario 3D, but I can put Microsoft Corporation there, publish Microsoft Corporation or something like that. I can call it a critical patch, and I can embed it in MySpace. And basically, most people actually click on run there. This is the simple unscript that I built to generically create these files. And it's very simple. You can actually modify any part of the signing process. It's very easy to use. And this is a simple file. It's actually as simple as that. We create a simple process. We run the calculator. Of course, we can do a lot more than that. If the user makes the mistake, which has a 50-50 chance to make the mistake, click on run. If you're actually going through executable, if an executable wants to run on your machine, there's actually more actions to be taken. First of all, the browser is going to ask you to download it. Then it's going to ask you to run it. And then Microsoft, the environment is going to ask you whether you trust this publisher. So there's 3 actions. You need to click on 3 boxes. In this case, it's just only one, 50-50, right or wrong. If you click on the right, that's it. This is another interesting thing. Adrian actually covered a little bit, the Flash UPnP hack. And I'm actually quite proud with this research that we did. And because this is most people didn't realize that we can exploit UPnP through the web. Because the UPnP protocol consists of a couple of other protocols. It has a simple discovery protocol, it has a couple of other discovery protocols, but also at the end of the day, it actually has a simple SOAP. Now, usually, we cannot forge requests from the browser using SOAP because we need to add special attributes to the request, like SOAP action and other things like that. However, as I said, if the browser does not allow us to do that, then Flash probably will. And this exploit here is a very simple exploit which actually attacks your router through UPnP. Now, the things that you can do through UPnP are very unique and very interesting. Some devices that allow you to reset the credentials. Some devices will allow you to do some change the domain, the DNS settings. Keep in mind that UPnP is authenticationless. There's no username and password thing going on in any single stage. It's supposed to work from inside your network, which is trusted, but it works also from the web, which is not trusted. And it's going to use your browser as a proxy to break into your home router. We can also do port forwards. We can do pretty much whatever your device supports. We can do that with send to URL. Now, the scary bit to me is that this attack is pretty much generic. This payload here is going to work regardless of your model. That's actually RFC. The only thing that is different is just the URL where you're sending it. So I can use now, basically I can build a dictionary of popular devices that has UPnP enabled, which by the way 99% of all of them has UPnP enabled. And I can put them into an array and start actually running through the whole thing with send to URL and just sending, and one of them is going to succeed, sending the exact same request. So when and this is also very easy to do that through some of this double-click advertisements and stuff like this. So we are talking about that if somebody actually starts implementing this attack, it's going to be a mass ownage because you're going to own the device completely. This is an actual SOAP request that we are sending. I'm gonna on this slide again. One of the most important things that the browser does not allow me to do is to set a header. I cannot do that, but with Flash I can do that. And here's the SOAP action, which I actually put inside, and then I execute the attack. As I said, it affects many embedded devices. It affects your Xbox. It affects my mobile phone. That device actually has a UPnP support. I can hack into it if it's on a network. It affects cameras and all sorts of other things. Now, this is something that I cannot talk about, but I can show you a video. This is a vulnerability in QuickTime, which actually, when executed, it successfully runs on Vista and XP, latest service packs. I disclosed it to the ZDI, the Zero Day Initiative, because I decided to try out the service just to see if it works well, and so far it worked really well. And they will get in touch with the vendor and stuff. So I'm going to show you very quickly the demo. This one is for Windows XP. I'm going to show you how it works. It's a simple test file, a movie file. Just one thing. This can be anything, any extension. It can be MP3, it can be .avi, .mp4, whatever extension you can think of, as long as it runs under QuickTime. So the attack basically starts a simple video, which is totally lame, and when it starts, it basically starts a couple of applications just to prove that I can start whatever I want there. But the fact is that, if I'm doing that, probably, the bad guys will install a complete backdoor on your machine. It's not going to do anything, like this. And this one is a little bit slow, so that's why I'm going to just scroll. So basically, I click on a file, that's Windows Vista box. And when this thing starts, I'm going to just... It basically starts the application. It's very slow because it's running on the VMware on 512 of RAM, so it's not very fast. But again, it just plays up, and after the attack is successful, it just starts Notepad, Calc, or whatever. Now, the interesting thing about this exploit is that it's universal and it just works on a platform. It works on Windows 2003, Windows 2000, pretty much on every Windows distribution you can think of. And to me, it's scary because it also runs through the browser, which means that if you visit the wrong page, that process is going to start automatically without even you asking you whether you want or not to preview a video. You just visit there and it starts. And the problem is that there's so many social networking websites, all of them allows you to embed QuickTime. So any of them can be used potentially for this sort of attack. And I'm hoping that I'll be able to actually talk about it in a couple of months' time about the details, because it's very interesting. And when I'm talking about embedded client-side security, my actually understanding is a little bit broader, so that's why I actually did also some networking stuff based on client-side security, and also again based on things like attacking actually design problems within the protocols. A lot of people don't look at them, but there's so many design vulnerabilities, it's not even funny. This one is a design vulnerability within DNS. To me, it's a very big design vulnerability. The problem here is that all this script does is it basically uses DHCP to create a name within a network. So for example, if you have a DHCP, proper DHCP environment, when I start the initialization process, I basically say, okay, where is the DHCP server? The DHCP server comes back and I start actually talking to the DHCP server and I say, I want IP address and this is my name. And when you actually provide your name, this is your computer name, and you will be known as that computer into that network, which means that I don't need to know your IP address, I can just type bang your name and it's gonna work because it's gonna result. Now this is basically the situation with most networks. Some networks don't work this way, but most of them work like that. Of course, because I can register any name that I want, I can use this simple script and basically register a bunch of names. Now how many people in corporate environments are using short names? Like for example, mail is actual mail, POP3, server into the organization, or intranet is the actual intranet site, or in case of Windows environments, we have something very fun which is called WPAT, which is actually the host which will provide you the configuration of your proxies. And probably if you followed the research on last year's on Black Hat, HD Moore actually showed how you can use WPAT to compromise a machine. Now, which means that if you have this internet settings enabled, automatic proxy configuration enabled, I can register WPAT settings right now, WPAT box, and when you open your browser and start to visit Google, I'm gonna deliver proxy settings to you that will allow me to break into your computer. And this is all the script does. Now, to me, this is a design problem in DHCP, and this is how it's supposed to work, but of course you can use it for malicious purposes. The other thing that is very interesting is that sometimes these settings actually are resident for maybe a week or something like that, and sometimes when actually assigning the IP address, I can assign an external IP address. So one possible way of attack is actually backdooring many wireless networks. So all the attacker needs to do is to take a laptop, just drive around and connect to open Wi-Fi networks and start registering external IP addresses to local names. And sooner or later, someone will actually start using these local names for whatever reasons. It could be your Outlook Express minimized, which actually tries to find mail and sends your credentials right away for authentication. The same thing can be done in Python. So this is just basically was recommended of some of the guys that commented on the blog. And the last thing that I would like to talk about is, yesterday we heard a lot of interesting things about using virtualization, malware, and things like that. But to me, I'm actually more practical, and I look at what is happening today and what is more practical to do. And the most practical thing is to attack your browser. And that's why I call it 4th generation rootkits, because they're very simple to write. They're very hard to detect. It's almost to the extent of being impossible to detect. And they're very polymorphic, because JavaScript, XML, RDF, all these technologies that are mixed up in your browsers and all actually client-side applications are completely morphable. I can write maybe billions of combinations of the same thing is going to work exactly the same way, which means that signatures won't work. Just forget about signatures. That's a myth in this sort of environment. And all this stuff, just simple text files, which means that I can write it over 2 hours, a new malware, and that's going to be fine. And you don't know how much this technology is involved into your computer. I mean, just JavaScript is probably the single most powerful environment on every single Windows machine ever, because PDF knows how to run JavaScript. Windows knows how to run JavaScript through Windows Scripting Host because it has JScript. Any Adobe product knows how to run JavaScript because they use JavaScript as a scripting language. Flash knows how to run JavaScript because it's based on ECMAScript. And some of the backdoors, some of the actually ways to exploit these vulnerabilities are very interesting. For example, one of the most simplest attack forms for if somebody wants to attack your browser, not browser, your client environment, is to get in touch with your Flash player. You can actually minimize the security settings of the Flash player to the extent where whenever you go, anybody can attack you. We can also install software within your computer, and that's just a simple configuration. So I mean, go actually write a a antivirus software that's going to actually tell you that this is wrong, because the antivirus software does not know whether this is the intended way of using it. And also, we can do very, very sophisticated attacks by actually minimizing, by actually reducing the security settings of your Flash player. We can actually sniff on your microphone when you go to a website. We can actually survey the room. If you don't notice if you have a camera, we can actually take pictures of you. We can do very sophisticated sort of attacks, and we can actually offload this stuff into a third-party server, which we can set up in maybe 5 minutes, because Adobe provides the facilities to do that. Simple streaming. We can probably even stream it to YouTube. And that's scary. And it's very easy to backdoor Firefox, and there's no way of knowing whether this backdoor is actually supposed to be a real extension or is actually actual exploit inside, because everything is text. Simple modifications of the source code will lead to huge compromises. Just recently there was a problem with the language packs. The language pack is actually an extension. I mean, and inside I can put whatever I want. And of course, when you install the language pack, you essentially allow arbitrary code running on your computer. As I said, obscure browser extensions. Extensions can remove themselves. You can install extensions for IE because it's written with HTML and written with JavaScript. Pretty much you guarantee that this code will run on every single environment. And because Firefox is ported on every single platform, this means that my code, I don't even need to take care of actually portability. The environment already takes care of me of this sort of a problem. And there's some other stuff there. And so this is a very interesting quote from Giorgio Mione. If today's malware mostly runs on Windows because it is the commonest executable platform, tomorrow's more likely to run on the web for the very same reason. And this is actually very true. I did some research on Web 2.0 security last year, and I was not concentrating on input validation bugs, but on what exactly is the problem with Web 2.0. If you think about when email was invented, the author was not, the actual designer was not thinking about spam, that wasn't an option. He didn't know what is spam. The same thing happens today. You design a technology, you have no clue how this technology is going to affect you in the future. And this is the problem. Now, the web today is the biggest backdoor to everything you can imagine. If you just turn off this port, you're going to be, hundreds of times safer. But of course, we cannot go without it. And again, I say the clients and services in symbiosis. One thing that I forgot to mention, but I just want to mention it, just recently there was some research on persistent attacks within the browser. And these are very cool because attackers can actually install a script within your browser. And even if you change locations and you go to google.com, you go actually to, natwest.com or bankofamerica.com, inside there is actually iframe, which actually sniffs exactly what you do. It doesn't sniff the traffic, but it sniffs all your keys. And it can sniff the locations. So now we have also keyloggers for browsers, which are very, very sophisticated. And they work in a very different way. And I always say that today compromising your box is not useful unless you want to attach to a botnet. It makes no use. All your data today is on the web. If somebody breaks into your email account, they can do actually a lot of bad stuff. If they can break into your, for example, social network account, again, it's a problem. And one thing that I actually was blogging a couple of days ago was a technology that will be introduced by Microsoft. It's called Live Mesh, which is a technology that allows you to sync all of your devices onto the cloud and also take all of your data and spread it across all of your devices, so they actually always sync. However, in order to access that interface, all you need is your Hotmail account. Now, I wouldn't trust bridging my Hotmail account with my computers. I mean, it makes no sense. Somebody can hack into my Hotmail, they have my password, Then from there, jump on my Live Mesh, have access to my mobile phone, my computers, everything that I possess, and all the files that I care about. And that's a problem. And this is basically the reason behind clients and security, because servers and clients are very dependent on each other, and because there is such a synergy between them, we cannot just take it off, test it, and you think, oh, that's cool, works. Take the other thing. In fact, the QuickTime exploit works because there's three technologies which do exactly what they're supposed to do in a secure way, but when you put them together, they're completely insecure. And because all of them are developed independently, yesterday we had a talk with Dennis Cruz and some other guys that basically this object-oriented programming is a joke. I mean, this basically creates most of the security problems because you develop a class that don't know how this class is going to be used. Basically, you just write it out, somebody gives you a specification, somebody takes the class and uses it in a way that you never imagined. That creates a problem. And yeah, they're very complicated, clients and servers, because they always have mix of interactive technology. And I always say that Firefox probably source code is a lot more complicated to read than actually the Linux kernel. Because Linux kernel tries to actually minimize the code, make it modular, make it nicer looking, and there's also a lot of performance problems there. So that's why the code needs to work in a minimalistic way. The browsers are actually expanding and they basically blow off. And this is my point. If you put two secure things together, they're usually not very secure. And this is pretty much it. If you have any questions, we can ask now. If you have more, if you have any time. No? Well, if there's no questions, thank you very much for attending the lecture.